This next topic sort of combines concepts of the triangle median and the triangle altitude. However, this is related to just a line segment, not to a triangle, so it works with any line segment, and it is called the perpendicular bisector. So the perpendicular bisector of a line segment is a line that intersects a line segment at a 90-degree angle, and it intersects it directly in the middle point. Okay, so the perpendicular part tells us that it's making a 90-degree angle. Bisector means it cuts it in two, and it is in two equal parts. Okay, so it is a line that intersects a line segment at the midpoint at a 90-degree angle. Okay, so if we were to just draw a quick picture, like let's say this is the line segment, the perpendicular bisector would go straight through and make a 90-degree angle with the line segment. So if you start with two endpoints of a line, these are the steps that you will take to find the perpendicular bisector. This is similar to the median and the altitude of a triangle in the sense that you are going to get an equation, and that equation will represent the perpendicular bisector. So steps 1, 2, and 3 can kind of be interchanged depending on your preference. I'm going to show the order that I usually do them in, but you can do step 3 first if you would like to. So what I do first is I find the slope of the line between the 2 points. Okay, so given your endpoints, you'd use your slope formula, and you want to figure out what the slope of the line is that would connect those points. Once you have that slope, you want to figure out the perpendicular slope. So this is similar to what we did with the altitude of the triangle. So you're going to do that by taking the negative reciprocal of your slope from step 1. And we need this because we know that the perpendicular bisector is perpendicular to the line segment. So that's why we want to find the negative reciprocal of the slope, because that will give us a line that intersects the line segment at a 90-degree angle. Then, because the bisector cuts the line segment in half, so it goes through the midpoint, we need to also find the midpoint of the line segment. And like I said, you could find this first if you would like. It doesn't make a difference if you do this first. And then find the slope. I just usually find the slope first. And that point we just call M. And then the last step is you are going to make an equation. And again, because it's a line, it's going to be y equals mx plus b form, slope-intercept form. And you are going to let your slope be your perpendicular slope. Okay, again, that's what that little upside down T denotes, is the perpendicular slope. And then you are going to use the midpoint for x and y. Okay, so that's what I mean by that. You'll let the x value equal the x coordinate of the midpoint, the y value equal the y value of the coordinate of the midpoint. Okay, and then you'll, again, simplify, isolate for b, and state your final equation. So if we look at an example of this, if we have the endpoints 2, 5 and 8, 3, we first are going to find the slope. And again, we do that by using our slope formula, which is lowercase m is equal to y2 minus y1. So I'm going to do 3 subtract 5 divided by x2 subtract x1, so 8 minus 2. And then we simplify, so 3 subtract 5 is negative 2. 8 subtract 2 is positive 6. And we are seeing if we can simplify that fraction any further. So we can divide both of these by 2. Again, we want to keep it as a fraction. If you type this in on your calculator, you will get a decimal number that is not very nice. And we cannot take the negative reciprocal when it's in decimal form, so leave it as a fraction. I'm going to put the negative sign out front because the entire fraction is negative. Then on the top, I will have 1. On the bottom, I have 3. So my slope is negative 1 over 3. I need to find the perpendicular slope because the equation I'm making is for the perpendicular bisector. So the perpendicular slope, again, is the negative reciprocal of the slope that I just calculated. So if my slope is negative 1 over 3, that means that my perpendicular slope is going to be positive because I'm changing the sign. I flip my fraction, so it's going to be 3 over 1, but I'm just going to write it as 3. Okay, if you prefer to keep the 1 in the denominator, that's fine. I wouldn't mark that incorrect, but it's just more proper to write it like this. Okay, so that's my perpendicular slope. Then I want to find the midpoint. And again, this is the midpoint of the line segment, so between those two endpoints. So I'm going to use my midpoint formula, which is x1 plus x2, so 2 plus 8 over 2, and then 5 plus 3 over 2, and then I am evaluating, so my midpoint is equal to 10 over 2 and 8 over 2, which gives me a midpoint of 5, 4. So then my last step here is to make my equation, y equals mx plus b, and I'm subbing in the values that I know here. So I'm going to let m be 3, x be 5, I've been getting that for the midpoint, and y be 4. And then I am subbing all of those things in to find my b value. So instead of y, I'm going to write 4 equals 3 times 5 plus b, and then I am simplifying and isolating. So this gives us 15 plus b. I'm going to subtract 15 on both sides to isolate. That gives us negative 11 on this side. So my final equation of the perpendicular bisector is going to be y equals 3x subtract 11. Okay, and similar to how I showed with the altitude and the median, if I were to graph those two endpoints and the line segment, as well as the equation of this line here, you would see that it would intersect the line segment at a 90-degree angle, and it would cut the line segment directly in